Hi guys, welcome to Mr. Shaw's class again. And I just wanted to point out that this video is no longer brought to you by the Cannonball. I went and purchased a arm off of Amazon that connects to my table and holds my phone. It's a wonderful piece of machinery. Let's see if it works. You know me in technology. So lesson 15 is the basis of trig. My students, you should all know trig very well. And if you don't,
Sine, opposite hypotenuse, sine, opposite hypotenuse, sine, opposite hypotenuse, cosine, adjacent hypotenuse, cosine, adjacent hypotenuse, cosine, adjacent hypotenuse, tangent, opposite adjacent, tangent, opposite adjacent, tangent, opposite adjacent. The long sides of hypotenuse and the other two sides depend on which angle you're focusing on. Pick one angle and look. There's one side that's the opposite. You can clearly see that there's also an adjacent side. Sine, opposite hypotenuse, sine, opposite hypotenuse, sine, opposite hypotenuse, cosine, adjacent hypotenuse, cosine, adjacent hypotenuse, cosine, adjacent hypotenuse, tangent, opposite adjacent, tangent, opposite adjacent.
I can't do it. I can't. It's too much for me. Okay, you guys remember that. I know you do. But let's do this. One of the things that he pointed out is adjacent and opposite depend on what angle you are looking at. Now, it's very difficult to read this, but this is A, this is B, this is C, this is 35.86. Great way to make it difficult by using decimals. 10.14, 7.33, 12.51. This is a right angle. If this is 35.86 and this is 90, what is this? Triangle angle sum theorem. We do 180 minus 90 minus 35.86 makes this required to be 54.14 degrees. Okay? That's just looking at this. That's just seeing everything that I can look at, doing everything that I can with just the information that's there. Would you do that on the SATs? No. Would you do that on my test? Yeah, probably. But moving on. All right. So when you go through the GeoGebra file and you're looking at all this stuff, just keep in mind that adjacent and opposite are from your reference angle. Let's take a look. How could you prove that all three of these triangles are similar? Well, we've already gone through angle-angle similarity. They all have a 90. They all have 35.86. There you go, angle-angle. Another way to do it, 10.14 is to 6.9 as 7.33 is to 4.98. And if you don't believe, trust the Shaw. 10.14 divided by 6.9 is 1.4 to the 7.33 divided by 4.98 is 1. See, I think this is because these are rounded numbers. This is why I don't like starting with decimals and stuff like that, because while this is by definition the angles make it similar, the measurements were rounded, so they're not. These triangles are not possible. One of them isn't. So 10.14 plus 7.33 must be bigger than 12.51. It is. This must be bigger than this. It is. This must be bigger than this. It is. So I don't know what's going on here. 10.14 over 6.9. 7.33 over 4.98. Something's going on here to make this not a true triangle. They're not similar, is all I'm trying to say. But let's assume that they are. We proved that they're similar using angle. The ratio of this over this has to be equal to this over this, but it's not. Okay, somebody rounded. Moving on. Compare the ratios of the opposite leg to the hypotenuse. The ratios of opposite leg to the hypotenuse for red, green, and blue triangles. Ratios of opposite leg to the hypotenuse. Opposite leg over hypotenuse. Opposite leg over hypotenuse. Opposite leg over hypotenuse. 7.33 divided by 12.51. 4.98 divided by 8.51. 1.69 divided by 2.88. Now these three numbers need to be identical. They're not. Ideally they would be. Let's assume that they are so we can get on with this lesson. The ratio of opposite leg to the hypotenuse are all equal. Even though they're not, they're supposed to be. You can change the size of the three triangles by dragging points A, B, or C. The triangles will be held similar. Adjust one or more points. Okay, you can play with that on the GeoGebra. Then compare the ratios of the adjacent leg to the hypotenuse for red, green. Okay, they will all be the same. They're not, but ideally they would be. Change the triangles again by adjusting one or more points. Then compare the ratios of opposite over adjacent. What do you notice? The ratios are all the same. Even though they're not, I'm telling you they're supposed to be. That brings about sine, cosine, and tangent. Sine is opposite over hypotenuse. You can see it right here. Sine, opposite over hypotenuse. Cosine, adjacent over hypotenuse. Tangent, opposite over adjacent. Now, one thing that I'm intentionally leaving out, that. What is that? Well, let me give you a brief history on what sine, cosine, and tangent are. They are numbers. They are numbers that depend on an angle. They are ratios. They are a decimal. They are a fraction that depend on the angle itself in a right triangle. So when you do this and you have these numbers, this makes it into a number. It's not sine alpha. Alpha, that means alpha. It's sine of that specific angle makes that specific ratio. What does that mean? That means that every single right triangle that has an opposite over hypotenuse with that number is similar to every other single triangle with that opposite over that hypotenuse. Let's move on and show you what I mean. Now, this video with introduction to trig ratios, that was a pretty good one. Read through the summary. I struggled a little bit. Maybe you won't. It could also be because I had a 2-year-old tugging on my leg to play with her and stuff. But complete this exercise with practicing finding the sine, cosine, and tangent. All right, let's use this to determine each of the following ratios. Sine of A. When you see sine of A, that means your reference angle is A. That means I'm starting here. When I do sine of A, I am going to draw my opposite. I'm drawing an arrow to opposite. Me personally, not you, you might. Me personally, I will always do that. The reason I always do that is because I make mistakes. But if I automatically mark my opposite, I will never forget which side is opposite. Which side is opposite? It's pointing to it. Sine of A. Opposite, sine is opposite over hypotenuse. Oh, 8 over 10. 8 over 10 is not the correct answer. No, it does not need degrees. It is a solid number. 8 over 10 needs to be reduced. 4 over 5 is the correct answer. See, now I would have used 6, 8, 10 because, Those are nice numbers, but hey, the angle measures aren't nice, but neither were the ones on the last page. Cosine of A. Cosine is adjacent over hypotenuse. Well, this is the opposite. This is the hypotenuse. That leaves this. This is adjacent. 6 over 10. 6 over 10 is not the answer. The answer, ladies and gentlemen, 3 over 5. Divide by 2, divide by 2, 3 over 5. Tangent of A is opposite over adjacent. TOA, opposite over adjacent. 8 over 6 is not the answer. Reduce, 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 reduce. 4 over 3 is the answer. Could you leave it as a decimal? Sure, I guess. But look what happened here when we're doing stuff with decimals. It ended up not being similar, didn't it? Keep it as a ratio, please. Now, for sine, cosine, and tangent of C, we are looking at a different angle. I'm going to break out my different colored pen. We are looking at a different angle. This is our new reference angle. I'm going to, without doing anything else, I'm going to draw my opposite. My opposite is now 6. 6 is opposite. 6 is no longer adjacent. 6 is adjacent to A. We're talking about C. 6 is opposite C. Sine, opposite over hypotenuse, 6 over 10. 6 over 10 reduces to 3 over 5. Cosine, 8 over 10. That's an 8. Reduces to 4 over 5. Tangent, opposite over adjacent. 6 over 8 reduces to 3 over 4. Now, I want you to see something. Notice that. You see that? Cosine of A is equal to sine of C. Look at sine of A and cosine of C. Those are also equal. This is what's called a mathematical observation. You look at stuff and you see math stuff. That's a mathematical observation. What can you tell me about these? Use the right triangle at the right to determine each of the following ratios. I want you guys to do this. I'm going to do F. I'm going to mark my opposite. I'm going to do E. And I'm going to mark my opposite. You guys can do that no problem now. Reduce, reduce, reduce. Guess what? That's prime. That's prime. You can't reduce this one. And that's it. Bye, guys.